Okay, so in this class we talked about the concept of an ion and how it related to atoms. So the big idea here is that atoms can gain or lose electrons. They're never going to be gaining or losing these protons, but they're going to be gaining and losing these electrons. Again, those particles flying around the outside of the atom. And they're going to do this to become more stable, and we're just going to leave it at that for now. So how many are they going to lose? We're going to practice this in a minute, but we're going to say they want to become like a noble gas, and these noble gases are kind of the stable group. So when they do gain and lose these electrons, they're going to form these new things called ions. An ion is just this charged atom. So when elements or atoms gain electrons, we need to think of what happens in your life when you gain negativity. When you gain negativity, you become more negative. So when you gain these negative particles, you're going to become a negative ion. And we call these anions. The way I'd remember this is an anion is a negative ion. So a negative ion is an anion. And conversely, like when you lose negativity in life, you tend to feel more positive. So we're going to say that when you lose these negatively charged electrons, you then become a positive ion, something called a cation. And however corny this is, we can think that cations are positive because they have a little cat thing there. Ha ha ha. Okay. Now in general, and we'll practice this also, but our metals over here on the left side of the periodic table are going to be the atoms and elements losing electrons, and the non-metals right here are going to be the atoms or elements gaining the electrons. And then to remind you that the charge of the ion is going to equal the protons minus the electrons. Okay, let's try some practice problems here. So indicate what the following atoms will do to become an ion. So indicate gain or lose along with the number. So remember, they're going to gain or lose electrons to become like a noble gas. So we have the alkaline metals, the alkaline earth metals, the transition metals, the halogens, group 16, and the noble gases. So I'm going to go to the periodic table first, and we'll go back and write all this down. So these right here are the alkaline metals. So if you look at the first example here, lithium has 3 electrons, and over here it could either shoot for helium or it could shoot for neon. Now in the world, whatever's easiest is usually what happens. So we could either gain 7 electrons to become like neon, or we could just lose 1 to become like helium. So lithium is going to tend to lose 1 electron. Sodium has 11 electrons. Neon's got 10, argon's got 18, so it could either gain 7 or lose 1. Again, it's just going to lose 1. So that's what the alkaline metals tend to do. They all tend to lose 1. Moving 1 over to the right, magnesium has 12 electrons, so it's stable. It'd like to have 18 or 10. So again, what's easiest? It'd rather just lose 2. So when it has 12, it loses 2. Now it's like a noble gas. Now these transition metals here, groups 3 through 12, it gets a little complex and stuff we'll talk about later in the year, but they just tend to lose electrons in general to become stable. Now over here on the right side, the group 16 elements, let's just look at oxygen. Oxygen has 8 electrons when it's stable. I guess the 2 it's in between are helium and neon again, so 2 or 10. I guess to say gaining 2 electrons would be the quickest way to a noble gas, and that's what all these group 16 elements are going to generally want to do, is gain 1 electron. Let's check out chlorine here, one of the halogens. So group 17 is the halogens. 17 in between 10 and 18, again, I think just gaining 1 electron is the quickest pathway to become stable here. And then lastly, what are these noble gases going to want to do? Probably nothing. They're just going to stay where they're at. So they're neither going to gain nor lose. So they're not going to tend to form ions. So let's go summarize that on our ion sheet. Alkaline metals are going to want to lose 1. Alkaline earth metals are going to want to lose 2. Transition metals are just going to lose, and we'll talk about the numbers later. Halogens are going to want to gain 1. The group 16 elements like oxygen are going to want to gain 2. And the noble gases are going to do nothing. They're just going to stay where they're at. Okay, for question 2 here, indicate the charge for the ion formed from the following atoms. So let's check this out again. So we got sodium. Sodium's going to want to lose one electron because it's in the alkali metals. So sodium has 11 protons, and it has 11 electrons when it's neutral. But if it loses one electron, it's now going to have 10 electrons. And then 11 minus 10, sodium is going to form a +1 ion. Okay, to the right, we got oxygen here. Oxygen is element 8, so it has 8 protons when it's neutral, along with 8 electrons. And we said it likes to gain 2 electrons. So oxygen will always have 8 protons. Now, if it has 8 electrons, but then it gains 2, it's then going to have 10 electrons when it's stable. 8 minus 10, oxygen likes to form -2 ions. Okay, next, fluorine. Fluorine has 9 protons and electrons when it's neutral. We said the halogens like to gain 1 electron. So instead of 9, it will have 10, kind of like oxygen. And then 9 minus 10, -1 ion. So magnesium. Magnesium was then the alkaline earth metal in this group 2. It has 12 electrons and protons when it's neutral, but it likes to lose 2 electrons. So it has 12 protons always. It has 12 electrons when it's neutral, but it likes to lose 2. So then 12 minus 10, magnesium likes to form +2 ions. Chlorine in the halogen group again. Chlorine has 17 protons and electrons when it's neutral. Clear up some of this. But it likes to gain 1, so instead of 17, it's going to have 18 electrons. So 17 minus 18 minus 1. Phosphorus. Following the trends we've been talking about, phosphorus is element 15 here. So when neutral, it has 15 protons and 15 neutrons. So to become stable, phosphorus would love to gain 3 electrons to become kind of like argon. So we go 15. So if it gains 3 electrons, it'll have 18, and that means it's going to love to be a -3 ion. Aluminum. Aluminum is outside of that transition metal. That's maybe a tricky one, so let's look at what it has. It has 13 protons and electrons when it's neutral, and it wants to have the same number of electrons as neon or argon. So what would be easier, gaining 5, or going all the way over here, and losing 3. Again, losing 3 is probably easiest, so that's what it's going to do. It's going to lose 3 electrons. So aluminum has 13 protons always. After it loses 3 electrons, it'll have 10 electrons, and then 13 minus 10 plus 3. So aluminum loves to form +3 ions. Now I'm just going to kind of follow a trend here so we can practice it. Nitrogen is right below phosphorus. So in that case, or it's right above phosphorus. We're going to say it likes to form the same charge as phosphorus then. So it's also a -3 ion. So this is how we can practice what charge the elements will, or what sort of ion the elements will typically like to form. Now what if we do a different type of problem? How many electrons are in the Cl- ion? Now that minus there, when it says just minus, that always implies a 1. So this is chlorine -1. So let's look back at our formula here, that charge equals protons minus electrons. So the charge is right here, -1. Chlorine always has 17 protons, always, always, always. I don't think it hurts to set up a little simple algebraic expression here to figure this one out. So -1 equals 17 minus what? 17 minus 18. Last one, how many protons are found in an Mg2+ ion? Let's forget about that whole charge and everything. Mg2+, magnesium's element 12. We already said that the protons will never, ever, ever change. Magnesium element 12, that means it's going to have 12 protons, and we don't need to do any math. Okay, I hope this helped review the concept of ions.